Gold extraction remains a massive global industry, traditionally relying on heavy engineering and chemical processing to unlock value from raw earth. Despite modern mechanical advancements, the industry's chemical backbone depends on a highly toxic solvent, sodium cyanide. The theoretical chemistry is remarkably lean. Dissolving 1 gram of gold requires just 0.49 grams of sodium cyanide. But industrial reality differs. Chemical and mechanical losses in leaching vats force operators to consume more than 200 times that theoretical amount. The current model of gold mining profitability relies on flooding ore with a massive surplus of an inefficient and hazardous reagent. That hazard carries heavy operational consequences. Governments globally are restricting or entirely banning cyanide use to protect local ecosystems. Even in legal jurisdictions, the financial liability is high. Generating toxic wastewater requires operators to build and staff expensive treatment facilities to manage the runoff. This creates a significant pressure point for mine operators, who must navigate impending regulatory shutdowns on one side and the risk of losing their profit margins on the other. Sector-wide skepticism remains high. Many operators assume that any eco-friendly alternative will inevitably lead to lower yields, complex overhauls, or costs that cannot scale. A viable solution must protect a mine's environmental standing while keeping its existing unit economics fully intact. The industry's hesitation is rooted in past failures, most notably with thiosulfate. This process tree shows why. Thiosulfate is non-toxic, but its dissolution rate is too slow, creating an operational bottleneck. To achieve industrial speeds, operators inject copper ions and ammonia. This accelerates leaching, but spikes reagent consumption and creates a chemical cocktail, making it difficult to recover gold. Previous green technologies failed to gain traction because they required highly volatile, heavily engineered processes rather than simple alternatives. JIN CHAN metallic ore dressing agent addresses these issues by providing a non-toxic alternative that resolves the tension between profitability and safety. For operations managers, avoiding capital expenditure is critical. There is no need to overhaul an active processing plant to accommodate a new reagent. As shown in this standard flowchart, JIN CHAN works with an existing infrastructure, including carbon-in-leach, carbon-in-pulp, and heap leaching systems. You simply swap the specific chemical input. The tanks, pumps, and flow rates remain exactly as they are. This drop-in capability removes the mechanical barriers to entry, moving the evaluation entirely to financial metrics. While sodium cyanide is often perceived as a cheap option, that view obscures the comprehensive cost per ton. To prove the economics, comprehensive field tests were conducted on oxidized gold ores at multiple global sites, including Sultan Kush and Tanzania BM. This chart compares the primary metric, leaching rate. Across multiple real-world samples, JIN CHAN achieved near-perfect parity with legacy cyanide. At Sultan Kush, cyanide achieved a 91.45% recovery rate. JIN CHAN matched it at 91.44%. The Sultan Kush evaluation showed an even larger savings of $1.16 per ton. This data proves unit price is a poor predictor of actual cost. Across the entire leaching cycle, the eco-friendly alternative yields a lower overall processing expense. The true cost of any extraction chemical must include the mandatory expenses of compliance and waste management. This quadrant chart plots toxicity against overall cost. Eliminating massive wastewater treatment places your non-toxic operations securely in the optimal bottom left position. You remove severe worker safety hazards from the floor and step away from the scrutiny of environmental regulators. Eliminating toxic liability functions as a direct mechanism for reducing long-term financial risk. If you are evaluating a transition away from cyanide, consider this final scorecard. Operations managers can integrate the reagent with zero capital expenditure and no equipment downtime. Financial officers achieve equal gold yields while structurally lowering the operating expense per ton. And environmental officers secure a fully eco-friendly operation that zeroes out regulatory risk. The transition to modern drop-in chemicals provides a decisive mathematical and operational advantage for industrial gold processing plants. High margins no longer require toxic trade-offs. It is time for gold plants to protect their bottom line by going green.